Okay, greetings geometry students. I appreciate you finding your way to Edmodo to view the notes. These are the notes that will be for class on Monday. Okay, but before we do that, we need to finish up the Cornell notes for the previous section. Okay, so what we need to do, the last thing that you're supposed to do for your Cornell notes is to create a summary. So what you need to do on that big long lesson that we had, again, apologize for the length of it, but read back over it, skim back over it, refresh your memories on what is in it, and we need to summarize the information that we learned. Okay, it doesn't have to be necessarily just one sentence, can be maybe two, maybe three. Doesn't have to be anything incredibly long, but you do need to be able to wrap your brain around the material that you've covered. Okay, so generate a summary for that last lesson before beginning tonight's notes. So go ahead and push pause if you need to, complete the summary, and then come back and press play on the video. Okay, today's information, or Monday's information, is going to be a deeper look at line segments and some of the measurements that will come along with that. We're also going to introduce what an angle is. Y'all should be familiar with that already, but we'll look at some of the vocabulary on the structure of angles, and we're going to look at the topic of bisecting segments and angles, and there's a bunch of synonyms that are going to come into play on that. So let's begin. Now that you have your summary written for the previous set of notes, now drop down a couple of lines and write yourself a new objective. Today's objective is the student will be able to solve problems involving bisectors and midpoints. We are going to pick up some extra information along the way, but this will be the skill that we're ultimately after. So copy your objective, put down the date. Monday's date will be September 9th. Pause the video anytime you need extra time to write, and then press play when you're ready to move on. Okay, now the first thing we're going to say is a word that we're going to use a whole lot this year, so we're going to want to become familiar with this one. If line segments have the same length, we say that they are congruent. Congruent is a word we're going to use a bunch. The basic translation of it is equal measurement. Okay, I know you learned in junior high, probably a lot of people when they hear the word congruent, they think same size, same shape. That actually applies to polygons, and we'll get to that a little later on, but we're going to use the word congruent for a lot of things, and just generally speaking, generically speaking, congruent means equal measure. We have a symbol that goes along with being congruent. It is that guy right there. It's an equal sign with what's called a tilde over the top of it. A lot of people just say it's a little squiggle, and that's fine. An equal sign with a little squiggle over the top of it. And that symbol shows that two things are congruent to each other. So in this particular diagram right here, as you can see, we have two line segments. Pronouncing them out loud, we have line segment AB and line segment CD. Along the bodies of the two line segments shown, we have measurements that are provided for us. In this case, we have 7 units on each of the line segments. Since we know that the overall measurements are the same, we could make the statement that line segment AB is congruent to line segment CD. And that is precisely how this is written and pronounced, okay, in the English language. Line segment AB is congruent to line segment CD. This is the particular language that you're going to get to need to be used to. You're going to be using it quite a bit. Another thing that we run into is if we know that line segments are going to be congruent, or maybe the person that put together a diagram is trying to communicate with us that we have line segments that are going to be congruent, there is a particular mark that is used. So many times if line segments are congruent in a diagram, they will use what are called tick marks. And here's what tick marks look like. So the same diagram, instead of the information, the 7 units being provided for us, you see they've replaced that with a little hash type mark in the middle of line segment AB, and then an identical one in the middle of line segment CD. This is communicating with us that the line segments are congruent, so the same statement can be made. Line segment AB is congruent to line segment CD. We no longer know the measurements of line segment AB and line segment CD, and that's going to be the case for a lot of geometry. It may not matter exactly what the measurements are, it only matters that the measurements are congruent to each other. So we will run into a lot of situations where tick marks are in our diagrams. Okay, now we're familiar with angles. It's certainly something that's been talked about before through our travels in junior high, but we're going to break it down and look at the actual definition and also the parts of the angle. Okay, and our basic definition here is an angle is composed of two rays with a common endpoint, and that common endpoint is called the vertex of the angle. If you kind of look at a parts breakdown of an angle, here's what you have. It takes two rays to do it. The rays will originate from the same endpoint, in this case B, okay? And those rays, of course, that common endpoint is called the vertex of the angle. Now, vertex is actually kind of a tricky term. We're going to end up redefining the word vertex several times throughout the course of the year of geometry. So this is the first real instance that we're running into. Okay, a vertex is the common endpoint of an angle. Okay. Now, we will run into some complicated diagrams throughout the year, and in order to make things as simple as possible, sometimes the angles will have names that we can refer to when we need them. Okay, and sometimes those angles will have a small number inside of them near the vertex that we can refer to it as. Okay, so in this particular diagram, we have an angle, appears to be an obtuse angle. We'll get to that another day. Okay, but you see down inside of the angle near the vertex, there is a little number sitting there. In this case, it is a 1. And this is a name of the angle that we can refer to. So when we're speaking about a particular diagram, we can ask the questions or make statements and simply refer to what's going on with angle 1 in the picture. We also have a little shorthand notation for angles. You see it down at the bottom right. It looks like something similar to a less than sign, but it has a little arc drawn across it, and it is pronounced angle 1. Now, it's important to note, okay, how do you know that this is a name of an angle as opposed to a measurement that is being shown in the angle? Well, how do measurements usually get written down when they show up inside of angles? With degree markers. Our angles are marked with degrees, 46 degrees, 122 degrees. Does this one have a little degree sign with it? No, it doesn't. Okay, so if it doesn't have that, then this must be a name of the angle that we can refer to. However, we're not often or not always fortunate enough to have the angles named for us. And in the event that we do not have a name to go along with the angle, then we are going to use what is referred to as the 3-point system in order to name the angle. Okay, so if we have the name of the rays of the angle, we will use the 3-point system to name the angle. The key is to have the vertex listed in the middle of the rays, and I'll get to that. Okay, the angle from the last page that we saw, okay, on the underneath parts of the angles, the definition of angle, that could be referred to as angle ABC, and you can get it out of alphabetical order, angle CBA. But the thing you should notice, in common with both of these names, ABC and CBA, look at what's listed second. Okay, the B is listed second in both cases. That's not an accident. B is the vertex, and when you're naming an angle by the 3-point system, the vertex always gets the second position in between the two endpoints for the rays. Now, just like with line segments, we have a way to show that angles are going to have the same measurement. Okay, it's not tick marks like it was with line segments, but we have a small arc that will appear down inside of the angle. Looks kind of like this. These are referred to as angle congruency marks. And whenever you see these guys, that looks like a little arc and it's positioned near the vertex on the interior of the angle, whenever you see these guys, Okay, if you see an arc in an angle in a diagram, and then in the same diagram there's another angle that has the same arc, they are relaying information to you that these angles are congruent to each other. We may not know what the measurements actually are, but whatever those measurements are, they are the same for both of the angles. So in this case, the statement that could be made right down at the bottom of the screen, it is pronounced angle DEF is congruent to angle XYZ. Now you may be curious as to how come we're using the 3-point system, going, hey, Mr. Hill, how come we can't just call it angle E, just name it after the vertex, or angle Y, just name it after the vertex? And that's a very good question, and there's a good answer that goes along with it, and we'll get to that as we move forward. But for right now, just understand that the 3-point naming system is going to be the deal, not just angle E, angle DEF, not just angle Y, angle XYZ. All right, the last topic that we're going to look at today is the discussion of midpoints and bisectors. Okay, I mentioned at the very beginning there's a lot of synonyms that go along with these kind of things. Let me tell you what I mean here. Okay, first off, I think midpoint is a definition that we know, but go ahead and scribble it down. Okay, something is a midpoint if it divides a line segment directly in half or exactly in half. Okay, obviously midpoint, middle point. Not very confusing on that. Kind of a synonym, different word, kind of coming at it from a different direction. If something has been cut exactly in half, we say it has been bisected. The prefix bi meaning two, and sected meaning having been cut up. Okay, so it has been cut up into two sections. Okay, so to put some of this vocabulary to work here, what we are looking at in this case is we have an overall line segment, JL, which is composed of two smaller line segments, JK on the left and KL on the right. If you look in the body of line segment JK and the body of line segment KL, we see tick marks. What do tick marks tell us? Tick marks tell us that those two lengths, the length from J to K and the length from K to L, whatever those lengths are, they must be equal to each other. Okay, so statements that could be made is that point K would have to be the midpoint of line segment JL because, or since, line segment JK and line segment KL are congruent. Other information that's coming out of this, okay, is the length from J to K is equal to the length from K to L. And remember, okay, that's what we talked about the other day. Here we have JK back to back, okay, with no marking over the top of them. That means the distance or the length from J to K. And of course, K to L with no mark over the top, that means the length or distance between K to L. So the length from J to K equals the length from K to L. Okay. So another statement, another way this could be worded is line segment JL has been bisected by point K. And one more definition I'd like to bring in here, a word that's going to pop up from time to time, is the term equidistant. Points J and L are equidistant from point K. If you break down the word equidistant, it pretty much tells you what it means. The prefix equi meaning equal and distant referring to the distance. Okay, this is all that we're doing for now, so take your notes. When you come to class on Monday, we will look at some examples and see how these segments and angles and midpoints and bisectors and all that stuff works with the math that's going on around it. I appreciate you finding time to take your notes, and I'll see you on Monday.